Hello, good evening students. Next concept is selection of electric loading and selection of magnetic loading. These things are very important. It will occur in DC machine, it will occur in induction motor, it will occur also in synchronous machine, but slightly changes as depends upon the machine parameters, slightly changes, but in this chapter it is very important. Write a short note or directly you may get the question. Discuss the factors effects on the selection of electric loading and magnetic loading and specify its values. It may be 8 marks, it may be 10 marks, number of times asked in VTU question paper, but you have to practice with full understanding, not simply write the stories. Now, very first one, choice of specific magnetic loading. First, you write the factors. You may get 2 marks for that. Same thing we have observed in factors affecting of length of air gap. Same thing, always you try to practice. First you write the following factors affects. After on, go on discussing each one because this only carries 2 marks. Okay. The choice of specific magnetic loading depends on number 1 iron loss, number 2 voltage rating, number 3 transient short circuit, number 4 stability, number 5 parallel operation. First you write, you may get 2 marks. After that few lines you discuss. Again number 1 iron loss. Higher value of B average, that is specific magnetic loading, results high flux density in stator teeth and stator core, which results an increased iron loss and also temperature rise. Definitely it will affect on efficiency of the system. Hence, what is the choice? Therefore, lower value of B average is used in order to increase the efficiency and to keep the temperature rise within safe limit. Hence, its higher value is limited by the temperature rise. How much temperature rise and what is the technology you are providing for cooling system, sophisticated cooling system, then system may becomes economical, uneconomical, all these factors are there. We can't take lower value, we can't take higher value, some medium value should be used, that is the idea. Number 2, voltage rating. In case of design of HV machines, the space occupied by the insulation is higher, larger space is required. Hence, space left for teeth is very less. Therefore, lower value of flux density should be used in HV machines to avoid the more flux density in teeth and core. That is the second aspect. Number 3, a high value of selection of B average results decrease in leakage reactance. It also results higher short circuit current. Hence, to limit the short circuit current, a lower value of B average can be used. Then, to remember this one, you have to develop some relations, that is B average inversely proportional to leakage reactance put in the block. By seeing this block only, you can construct 2 lines. After that, B average is directly proportional to short circuit current. Higher value of B average, leakage reactance. Higher value of B average, higher short circuit current. In this way, you remember these blocks. It makes very easy to explain. Number 4, stability limit. The maximum power in a cylindrical rotor machine can deliver under steady state condition. P maximum equal to EV divided by XS. E is the induced EMF, V is the terminal voltage. The important factor is XS, where XS is synchronous reactance in ohms. The maximum power or steady state limit of machine is inversely proportional to synchronous reactance. If we are selecting higher values of B average, then flux per pole is large, hence less number of turns are required for armature winding, which results less value of synchronous reactance. Hence, selection of higher B average improves the steady state limit. You remember, you have to make two blocks. B average is inversely proportional to XS. Higher B average, lower value of XS. Then higher B average or lower value of XS, it is related to stability limit. Higher value of B average, less XS. Higher of B average, improve in stability limit. Then same thing depending upon the XS, higher B average, less XS. Then synchronizing power, less XS, inversely proportional. If XS is low, synchronizing power is high. That is required to keep the alternators in synchronism. So, the satisfactory parallel operation depends upon synchronizing power. Higher value of synchronizing power keeps better parallel operation in the power system. Hence, you make the two blocks. One B average is inversely proportional to XS. We are using the higher B average, then XS value is less. XS value is less, then it improves the synchronizing power, better parallel operation. You remember these blocks, convert into explanation. Next, very important another factor, choice of electric loading. The choice of electric loading, that is the choice of current density. Now, choice of electric loading depends on many factors. Very first is copper loss and temperature rise. Second one, voltage rating. Third one, synchronous reactance. Fourth one, stray load losses. It is well known, if we are passing higher current, that is we are choosing higher electric loading, then higher electric loading results higher current passing through the conductors, which creates more copper loss, which creates more heating effect. Then it also contributes decrease in efficiency of the system, and it increases the temperature rise. The value of AC used, it mainly depends upon type of cooling technique employing in the system. If you want to use the higher value of electric loading, then you can use better cooling techniques, better insulation, that is the meaning. Number 2, voltage rating. A higher value of AC can be used for low voltage rating machines because space required for insulation is small. Number 1. Number 3, synchronous reactance. The value of synchronous reactance also affects on the selection of AC. The value of electric loading also affects the leakage reactance and armature reaction. Thus, higher value of electric loading results higher values of leakage reactance and higher values of armature reaction, which results the high value of synchronous reactance. This high value of synchronous reactance will affect in many way. Already we have seen less value of XS is required, higher value of XS. First it will affect poor voltage regulation, then low current under short circuit condition, then stability limit, poor stability limit, and low synchronizing power. These are all disadvantages or which are depends upon synchronous reactance, thereby the selection of specific electric loading. The stray load losses, it also affects directly. If we are using the higher current values or higher electric loading, the stray load losses in the system also increases. Hence, to reduce the stray load losses, lower values of ACs are preferable. After that, you have to remember approximate values of particular. First one, specific electric loading possible values used in machines. Give the typical example. Approximately you can write for salient pole machines 20,000 to 40,000 angstrom per meter or ampere conductors per meter. In case of turbo alternators, 50,000 to 75,000 angstrom per meter. Similarly, specific magnetic loading values used for number 1 salient pole machines 0.5 to 0.65 Webers per meter square. In case of turbo alternators 0.54 to 0.65 Webers per meter square. These are the values. These 2 points only get 4 marks. If question comes directly, briefly discuss the factors affecting choice of magnetic loading and electric loading, specify their values, means you have to write very carefully. Thank you. Don't neglect. Thanks to one and all.